Alright, so in this problem, I have x to the power of 4 is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and I get x to the power of 4 minus 4 is equal to 0. Now, I'm going to rewrite 4 here as 2 squared. So now I have x to the power of 4 minus 2 squared is equal to 0. And I'm going to write x to the power of 4 as x to the power of 2 times 2. So I have x to the power of 2 times 2 minus 2 squared is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite that as x to the power of 2 to the power of 2 minus 2 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. Now, this gives me two equations. I get x squared plus 2 is equal to 0, and I also get x squared minus 2 is equal to 0. So to start, for x squared plus 2 equals 0, I'm going to subtract 2 on both sides. So then these two cancel out, and I'm left with x squared is equal to 0 minus 2, which is negative 2. Now I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 2. Square root of x squared is obviously x, so I have x is equal to positive or negative square root of negative 2. And the square root of negative 2, I can rewrite this as the square root of 2 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I have x is equal to positive or negative the square root of 2 I. Now for this one, I have x squared minus 2 equals 0. So this time I'm going to add 2 on both sides. These two cancel out. And I get x squared is equal to 2. And now I'm going to take the square root on both sides. Square root of x squared is x. So I get x is equal to positive or negative square root of 2. So now to check, that is actually, those are our 4 solutions to this problem. Alright, so in this problem, I have x to the power of 21 plus x to the power of 14 is equal to 36. So I'm first going to rewrite this as x to the power of 7 times 3 plus x to the power of 7 times 2 is equal to 36. Now, I'm going to put this as x to the power of 7 to the power of 3 plus x to the power of 7 to the power of 2 is equal to 36. Now I can let x to the power of 7 equal to the variable y. So now I have y to the power of 3 plus y squared is equal to 36. Now if I subtract 36 on both sides, these two cancel out, and I get y to the power of 3 plus y squared minus 36 is equal to 0. Now negative 36, I can rewrite this as negative 27 minus 9. And now I can rewrite this as y to the power of 3 minus 3 to the power of 3 plus y squared minus 3 squared is equal to 0. So if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I can rewrite y to the power of 3 minus 3 to the power of 3 as y minus 3 times y squared plus 3 squared plus 3y, plus I can rewrite y squared minus 3 squared as y plus 3 times y minus 3, and this is equal to 0. Now if I factor out y minus 3, I get y minus 3 times y squared plus 9 plus 3y plus y plus 3. This is equal to 0. And this is simplifies into y minus 3 times y squared plus 4y plus 12 is equal to 0. So this gives me two equations. Y minus 3 is equal to 0, which means y equals 3. This is one solution. And y squared plus 4y plus 12 is equal to 0. So to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm not going to waste your time actually plugging them in, but if you do, you end up getting that it's less than 0, so this won't work out. So y equals 3 is my only solution to this equation. Now remember how we let x to the power of 7 equal y. So now I have x to the power of 7 equal 3, meaning x is equal to the 7th root of 3. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 as x to the power of 3 squared. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now if I substitute in x to the power of 3 for y, or sorry, y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now I'm going to factor this by rewriting this as y squared minus 2y plus y minus 2 is equal to 0. Now I'm going to factor by grouping, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 is equal to 0. For y minus 2 equals 0, y equals 2, and for y plus 1 equals 0, y equals negative 1. Now remember how we let x to the power of 3 equal y. So now I have x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So for x to the power of 3 equals 2, I can simply take the cube root on both sides. So now I have x is equal to the cube root of 2. And for x to the power of 3 equals negative 1, again, I'm going to take the cube root on both sides, so I get x is equal to the cube root of negative 1, and the cube root of negative 1 is simply negative 1. So I have x is equal to negative 1. So these are my two solutions to this problem. Alright, so in this video, I'm going to solve the equation 4 to the power of x squared over 2 to the power of x is equal to 8. So the only variable I'm solving for, and the only variable that's in this equation, is x. Now for my solution, I first start by writing my equation down here. So I have 4 to the power of x squared over 2 to the power of x is equal to 8. And what I'm first going to do is start by rewriting 4 here as 2 squared. So I have 2 squared to the power of x squared over 2 to the power of x is equal to 8. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x squared is going to equal 2 to the power of 2 times x squared. Now I have this over 2 to the power of x is equal to 8. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of 2x squared over 2 to the power of x, that's going to equal 2 to the power of 2x squared minus x, and this is equal to 8. Now 8, I'm going to rewrite this as 2 to the power of 3. So now another property of exponents is that if I have something in form a to the power of m is equal to a to the power of n, this means that m is equal to n. In other words, if the bases of two expressions are the same, that means the exponents are equal to each other as well. So now I have 2 to the power of x squared minus x is equal to 3. And if I subtract 3 on both sides, I get 2x squared minus x minus 3 is equal to 0. So now to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 2, b is negative 1, and c is negative 3. So I get x is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 2, times c, which is negative 3. And I have this all over 2a, so 2 times 2. So now this is equal to 1 plus or minus the square root of 1 plus 24 over 4, which is equal to 1 plus or minus the square root of 25 over 4, which is equal to 1 plus or minus 5 over 4. So now this gives me two solutions. I get x equals 1 plus 5 over 4, and x equals 1 minus 5 over 4. So for x equals 1 plus 5 over 4, I get x equals 3 over 2. And for x equals 1 minus 5 over 4, I get x equals negative 4 over 4, which is negative 1. So now, going back here, I have 4 to the power of x squared over 2 to the power of x equals 8. So I'm going to check these two solutions. So I'm going to first start with negative 1. So if I plug in x for negative 1, I get 4 to the power of negative 1 squared over 2 to the power of negative 1 is equal to 8. So 4 to the power of negative 1 squared is the same thing as 4 to the power of 1, because negative 1 squared is just positive 1. And 2 to the power of negative 1 is 1 over 2. So this turns into 4 times 2 is equal to 8, and 8 is equal to 8. Now I'm going to check x equals 3 over 2. So I have 4 to the power of 3 over 2 squared over 2 to the power of 3 over 2 is equal to 8. So 3 over 2 squared is 9 over 4, so I have 4 to the power of 9 over 4 over 2 to the power of 3 over 2 is equal to 8. So now to solve this, 4 to the power of 9 over 4 is the same thing as 4 to the power of 9 to the 4th root. So what I'm going to do is I'm going to rewrite this as 2 squared to the power of 9 over 4 over 2 to the power of 3 over 2. So now, let me rewrite this over here. Two times 9 over 4 is 18 over 4, so I get 2 to the power of 18 over 4 over 2 to the power of 3 over 2 is equal to 8. So now I get 2 to the power of 18 over 4 minus 3 over 2 is equal to 8. 18 over 4 minus 3 over 2 is equal to 3. So I get 2 to the power of 3 is equal to 8, and 8 is equal to 8. So this is right.